memory that holds information temporarily. We'll also look at storage, where data lives long-term, and the parts that let us interact, like the keyboard and screen. Understanding these pieces helps us see how computers do so much, so fast. We need to follow electrical safety guidelines to keep ourselves and our equipment safe. Electrical devices have specific power needs. For example, AC adapters are designed for particular laptops. Using the wrong adapter can damage both the adapter and the laptop. Printers also have parts, like power supplies, that carry high voltage. It's important to check the printer manual to know where these high-voltage components are before you start any work. Safety first, always. Electrostatic discharge, or ESD, can sneak up on us when a buildup of static electricity jumps between surfaces. It's invisible, but it can seriously damage computer components if we're not careful. To keep things safe, we follow some simple steps. We keep parts in anti-static bags until installation. We work on grounded mats, both on benches and floors. And we wear anti-static wrist straps when handling sensitive hardware inside computers. These precautions help us avoid costly damage and keep everything running smoothly. In this lab, we're focusing on safety, a crucial part of working with computer hardware. We'll cover 4 key areas. First, personal safety, how to protect yourself while you work. Then, electrical safety, because electricity demands respect. Next, fire safety, knowing how to prevent and respond to fires. Finally, compliance with government regulations, making sure we follow the rules to keep everyone safe. Together, these steps create a safe environment for building and servicing computers. Now, let's take a closer look at the core parts that make up a personal computer. These are the building blocks, the components that work together to bring your machine to life. From the processor that handles calculations to the memory that stores information temporarily, each piece plays a critical role. Understanding these components helps us see how a computer functions as a whole and sets the stage for everything we'll explore next. When it comes that holds everything inside, the power supply, motherboard, CPU, memory, drives, and cards. When we talk about form factor, we mean the physical design and layout of the case. Common desktop cases come in a few main shapes and sizes, each suited to different needs. Let's talk about power supplies, the unsung heroes inside our computers. They take the AC power from the wall and convert it into the lower voltage DC power that all the internal parts need to run. We started with the advanced technology, or AT, which powered older systems. Then came ATX, an updated version that improved things. Today, the most common is ATX12V, and for high-end desktops and servers, there's EPS12V, built for heavy-duty performance. These form factors shape how power supplies fit and function inside our machines. A power supply isn't just one plug, it has several different connectors. Each one powers a specific part inside the computer, like the motherboard or the disk drives. For example, there's the 20 or 24-pin connector that usually hooks up to the motherboard. Then, SATA and Molex connectors power storage devices. You'll also find smaller connectors like the Berg, auxiliary power connectors, and PCIe connectors for graphics cards. Each plays a key role in keeping the PC running smoothly. A computer can handle small ups and downs in power, but a big swing can make the power supply fail. Power supplies come in different